This video lecture is dealing with the idea of concentration of solutions and molarity. When we think about molarity, we're dealing with aqueous solutions. Molarity is when we have the same compounds, but the proportions may be different. We kind of talk about molarity being concentration. Notice that it is a capital M to abbreviate molarity, and that's moles of solute divided by the volume of solution in liters. A couple things about that. When we say volume of solution in liters, we're talking about the total volume that's being occupied. Remember, solute is what's being dissolved, and then the solution itself is being made by dissolving that into water, whatever medium it might be. When you mix a solution, you want to find the molarity. You have to know the mass of the solute. You convert that to moles. You put that into the flask first, and then you add the volume that you need of this solution that you're dissolving, whatever the solvent is, and then you can find the concentration by taking the moles divided by the liters of solution that you've made. Now, a couple things about molarity equations and how this works. Molarity is something that we see expressed with masses first when you're making it. So, for example, if we had 23.4 grams of sodium sulfate, and we wanted to know that we wanted to make 125 milliliters of solution, we could find the molarity. First thing that we'd have to do is we'd have to convert 23.4 grams of sodium sulfate into moles by using the molar mass. And when you look that up off the periodic table, that's around 142 grams. Your grams of sodium sulfate cancel, and you would end up with 0.165 moles. You got to get it into moles. Now, from that, if I have 0.165 moles and I have 125 milliliters, I have to convert the milliliters into liters. So there's 1,000 milliliters in a liter. So this is 0.125 liters of solution. Now I'm ready to do the molarity. Big M is molarity, and again that's moles, 0.165 of solute divided by 0.125 liters of solution, and that gives me a molarity of 1.32. Now, thinking about what that means, if the molarity is 1.32, that's moles of solute divided by 1 liter of solution. That's what that means. Let me erase this. Should be 0.132. 0.132 moles per liter of solution. So when you express a molarity quantity, we just write capital M. That equals 0.132 moles per 1 liter of solution whenever we express that. So molarity is a way of expressing concentration in aqueous solutions. We can also look at this when it comes to ionic compounds. If we had something like 0.025 molar, that's how we say it, calcium nitrate. Something that's a strong electrolyte, definitely soluble in water, and we wanted to know how many calcium ions it has and how many nitrate ions it has. Those would be my unknowns. Well, thinking about molarity and some stoichiometry here, if you start off with 0.025 molarity and you break that down to moles per 1 liter of calcium nitrate, and we do moles on the bottom, 1 mole would have 2 moles of nitrate ions. And the reason you would have that is because there are 2 in this formula. So if you multiply that, 0.025 times 2, you would have 0.050 moles per liter of solution, which is molarity. So you simply are multiplying it by the number of ions that are in that solution. So that's a way you can look at ionic compounds and see how that works in solution. When we think about dilution and how that works, dilution itself is a way of looking at taking something concentrated and diluting it down or adding more solution to it. So if we're thinking about trying to dilute something, the base equation for that is M1V1 equals M2V2. You've seen before in Chemistry 1. The reason that this works is that the moles before dilution are equal to the moles after. That's why this works. Because if you think about how that would work out in the molarity equation, molarity is equal to moles per liter. So if we go ahead and we multiply both sides by liters, liters cancel out, so now this is where the M1V1 comes from. The M1 is molarity, the V1 is in liters. Now it doesn't always have to be in liters when we set this up, but if we look at the before, that equals M2V2 because the amount of solute has not changed within that dilution. So what you've got is if you know 3 of those 4 unknowns, you can solve for any part of the dilution equation. But it's based on the idea that the number of moles are equal. We'll talk more about stoichiometry in the lectures later on. Take a look at this, and we'll work some more molarity problems tomorrow.